Now we're going to do operations with radicals. We're going to add and subtract them, multiply and divide them, and have a great time. Okay, so we can only add and subtract like radicals. Okay, it's kind of like variables. You can only add and subtract them if they're like terms. Same thing here. So let's just jump right in. I have 2 pieces of paper with square root of 5 written on it, and I take away 7 pieces of paper with square root of 5 written on it. So I owe you 2 pieces of paper with what written on it? Square root of 5. Done. Now I look at this next one, and these two are alike. I have 12 pieces of paper with radical 30 written on it, and another 5 pieces of paper with radical 30 written on it. So altogether, I have 17 pieces of paper with what written on it? Square root of 30. This guy is out in the cold. Because they're not alike, I can't do anything else with it. Let's look at this one. Okay, let's pair the like guys. All right, I'm psyched because there's really a 1 in front of here. These guys are alike. 4 pieces of paper with square root of 3 written on it. Take away 1. I have 3 pieces of paper with square root of 3 written on it. Now there's a 1 in front of here. These guys are alike, so a total of 11 pieces of paper with square root of 2 written on it. You're saying that to yourself. Now we look at D. Well, I can't do anything with it. But I really can, because both of these are not simplified. So I need to simplify first. So it's 2 square root of 50. Well, over here I can do 50 is 2 times 25. 25 is 5 times 5. So I do 5 times 5 times 2. This 5 comes out as a single 5. Oh, but I already have a 2 in front. But they're connected by multiplication. So this is 10 square root of 2. Awesome. Now, over here, we're going to simplify the square root of 32. Well, 32 is 16 times 2. Now, you're like, wait a minute. I know that 16 is a perfect square. So I already can just pull it out as a 4. Yes, that is correct. Or you can do 4 times 4 and get a pair of 4s and do it that way. Or you can even break it down into 2 times 2, 2 times 2, and get 2 2s. Get it? So I can bring this out as a 4. It goes in front, you guys. So now, this is what I call a rigged problem, where then you will get down to a common radical. And so now this is 6 square roots of 2. Perfect. Nice. Let's do a couple more just to kind of firm it up. So I don't break out into a cold sweat that all these are different, okay? You got to simplify it in there. So the first one, I'm just going to simplify. 32 is 16 times 2 times the x. The 16 comes out as a what? 4. Now I'm taking shortcuts because I'm kind of getting it. 2 times 4 is 8, and inside is 2x. Now what are we hoping for? We're hoping this problem is totally rigged. Now 72. Well, 72 now is, I'm going to do that over here, you guys. It's really 8 times 9, and 9 is 3 times 3, but 8 is really 2 times 4, and 4 is really 2 times 2. Cool. So for 72, I'm just going to take my time, you guys. I have a pair of 2s and a pair of 3s, so both come out, and 2 times 3 is 6, and I'm still left with 2x inside. Boom, ba. If you saw that 72 was 36 times 2, you're golden, baby, because the 36 comes out as a 6. Let's do the next one. Well, 12 is awesome because I know that 4 times 3 is 12. And I know that 6 times 2 is 12. And I could break that down further and see that I have a pair of 2s. But if I could see this 4 immediately and that comes out as a 2, I'm totally psyched. 4 times 2 is 8. And I still have a 3x inside. Good? Perfect. Everything is going according to plan. I have 2 of them that are alike and 1 that's different. So 8 take away 6 is 2 square root of 2x, because I have 2 pieces of paper left over with 2x, square root of 2x written on them. And this guy, well, he can't be done. So I just leave it in that form and everything is really good. Now let's do the next one. The next one is super fun. So what we're going to do is we're going to simplify all of these first, and I'm just going to write x cubed out as x times x times x. Perfect. So 100, the square root of 100 is 10. That comes out as a 10. And then I have a pair of x's, and I have a little x guy left in there. This guy, nothing. I can't do anything with him. 36 comes out as a 6, and we have a pair of x's that comes out as a single x, and I get x inside. Perfect. So now these are all alike, aren't they? Good? So 10x plus 3x plus 6x minus 6x will give me 7x square root of x. Cool? This one's a little different because I really have to make sure that both the x and the square root of x are the same in all of them. Good? Now, the next. Ooh, let's simplify cube roots, can we? Yeah, let's. So here we go, you guys. This isn't so bad, but I know I can't add these up yet because they are not common. So let's break down 81. Well, that's 9 times 9. And then the 9s break down as 3s. So the cube root will be 3 times 3 times 3 times 3. And then 24, you guys, that's 2 times 2 times 2 times 3. Do you believe me? Do you believe me? Let's do it. 2 times 12. 2 times 6. 2 times 3. Look at how good I am sometimes. Now here we're cube rooting it, so a triple comes out as a single. Cube rooting it, a triple comes out as a single. Ooh, my radicals are like, I can add them up. Perfect. Watch where you write your little radical guy. He's got to be in there, that's guy. He got to be tucked right in there. Now let's do multiplication. Okay, here's the scoop. We used this before when we simplified. You can multiply the numbers underneath the radicals. Okay, so let's do it. 18. Oh, but if I put that into my homework assignment on the computer, it would say, although your answer is equivalent, it needs to be simplified. Okay, so now we're going to just break her down. 9 times 2, and the 9 comes out as a 3. Because we're in square root territory, we only need a pair to come out as a single. Now let's do this one. This one seems crazy, but we're going to multiply the coefficients and then multiply the numbers underneath the radicals. And then I would say to myself, well, I'm done. But I'm not, because I can simplify the square root of 45. That's 9 times 5. And the 9 comes out as a 3, right? And 3 times 8 is 24. square root of 5. Unlike addition and subtraction, your numbers are going to change underneath the radicals. But once you get into addition mode, you guys, the radicals are like, I'm staying as I am, okay? Next. Ooh, look at this guy. This guy looks like fun. 3x square root of 5 times 3x square root of 5. So multiply your numbers, your coefficients together, 9x squared. Square root of 5 times square root of 5. Multiply your numbers underneath the radicals. Boom, ba. So it's 9x squared times, what's the square root of 25? 5. So this will be 45x squared. No radicals involved. They're all out. Okay. The challenge is, a lot of times you're like, oh my gosh, can I simplify further? Once a number or variable is out of the radical, it stays as is. I know that sounds crazy, so don't try to simplify it more. Once it's out, okay? D, let's multiply the coefficients in front. 3 times 15 is 45. X to the, oh, now we have to put our thinking caps on because we now have 3 x's, 4 y's. Add your exponents. Now I'm like, whew, that's over with. No, not so fast because we got to simplify. But don't panic. 45 is 9 times 5. I have 3 x's, 4 y's. Good? So 9 comes out as what? As what, people? 3. There's a pair of x's, comes out as a single x. 2 pairs of y comes out as yy. And now we just multiply and dump it all in front and see what the fallout is. 8 times 3 is 24. X, y squared. And inside becomes 5x. Bada bing. Next. Next, we're going to use the distributive property to simplify this. So we're going to distribute the square root of 3. So the first thing is 2 square root, we multiply the numbers underneath the radical, 9, minus 4 square root of 15 times the square root of 3 would be 45. So now we simplify. Well, the square root of 9, the 9 comes out as a 3, so 2 times 3, 6. Now here's the deal here. How many times have we seen this? 9 times 5 is 45. The 9 comes out as a 3. 4 times 3 is 12. Square root of 5. And of course we can't combine these because this guy has no square root here. So that's all you can do. Next is what we call rationalizing the denominator. So what we're going to do is get the radical out of the denominator because it's just not done in math. So what we're going to do is multiply the top and the bottom by the number 1. And the number 1 we're going to pick is the actual square root guy. So if I multiply the top together, it'll be 3 square root of 6. And then if I multiply my bottoms, I'll get 6 times 6 is 36, square root of 36. So that's just 6. And now they still have whole numbers in front, and we just reduce those. Square root of 6 over 2, because 3 goes into 3 once, 3 goes into 6 twice. So there. And now notice that there's no longer a square root in the denominator, so we're really super psyched. Next, first we're going to break this up. And then we're going to multiply the top and the bottom by the square root of 8. Square root of 8 times the square root of 8 is the square root of 64, and that'll just be 8. At this point, you probably will say, well, the square root of 8 times the square root of 8 is just 8, and you can bypass that middle step. That's fine. Square root of 3 times 8 is the square root of 24. Now I could leave it as the square root of 24, but we're going to simplify that as 4 times 6, and the 4 comes out as a 2. So this is 2 square root of 6 over 8. And then, of course, the 2 and the 8 can be reduced, so my final answer will be the square root of 6 over 4, and I am done. Now you guys can do this homework assignment on this lesson. Good luck. Ask lots of questions. If you need clarification, go to your instructor, because that's what they're there for.